Hello. Hi, good morning. My name is Abiodun Adetayo Adegunwa with the student ID 20193636. I'm, I'm presently studying a MSc in data science with internship, and today I'm presenting uh, assessment on the research analysis on data analytics and predictive modeling on dry beans dataset. Under the assessment title, develop and evaluate a prediction model using various data science techniques. So, like I mentioned earlier, I'm working on driving data set, which is gotten from a popular open repository, which is gotten from a popular open machine learning repository called UCI. So this is a copy of the data set. It has a 17 attributes, and then starting with, I would like to get us through take us through the source code with which I succeeded in building a model on this very project. So starting with, what I did was to get a data frame of this data set through this function, and that's what gave us the DF through a Jupyter notebook. And I had a head display of this data set giving me the first 5 entries by default, which actually shows the real attributes that are associated with its data set. There are 17 numbers, and from what I can see here, they are all numerical except for one attribute, which is a class attributes, as you can see here. So that means something in this exercise. So let's just take note of that and move on. I mean, at least that one has told us something about the data sets I'm working on. And moving forward, I have the info of the data set, which is a function. What simply tells us is giving us information about the data. First of all, it shows that we have 13,611 entries, and also, like I mentioned, 17 columns of the data set, and an hint on the numerous attributes that we have, which are 17 numbers from 0 to 16, and then some facts about the inputs, as in the values of the variables that we have, and the type of the variables, like the area is an integer, and the the parameter as floats, like that down, and again, this shows that the class variable, which is the last one as shown earlier, is a class, is an object. So again, that has a lot to do with the work at hand. So let's just take note of that. So moving on, the need for us to understand the nature of the data we are working on again comes the need for us to do a drop on some missing values if there are any. But for us to really confirm if there are any missing values here, we did a drop function on that and a print of it with this function. So that shows clearly, tells clearly that there is no missing values. So that saves me a lot of energy and extra work. So moving on, no need for dropping any value in this regard. And furthermore, I did a value count on the target variable, which is categorical, in nature, the class as shown earlier. These are the classes under the class, the Sika, Damascene, and so on. So the value counts we have done on that to really know what are the classes under that target variables that we have. There are about 7. There are 7 in number. And going forward, the describe function on this data set reveals clearly that we have reveals the statistical value of the attributes we have in all. It shows the standard deviation, the mean, the count of on the attributes, the data set, the minimum and the maximum, and so on and so forth. And then going forward, I did a box plot with a histogram. All of this is trying to get to know, understand my data. So that's the box plots, the histogram as well, and as well did a correlation matrix with this function, and as it clearly explained there, that simply what that simply means is trying to find a correlation coefficients for the correlation coefficient between two attributes in all of the data sets. So, and what that explains to us is that knowing fully well that the correlation coefficient ranges between -1 and +1, it shows again that when it's close to 1, it means that there is a strong positive correlation between those two features, between those two attributes. When the coefficient is close to -1, it simply means that there is a strong negative correlation. And what that means is, as one increases, the other decreases. While the zero coefficient showing is close to 1, that means that there is no linear correlation between those two attributes at all. And that is clearly what we have here. You can see these are the attributes, and this is the range of coefficient of correlation coefficients starting from -1 to +1. So when it tends, the areas that are blue, that tends to be blue, deeper blue, means the deeper the blue is tending towards, showing us strong correlation, there's positive correlation between those two features. Where it shows a red ranging from a light red to deep red, showing that there's a strong negative correlation between those two attributes. And where we have 0, that means clear white indication shows that there are no correlations at all, linear correlation between those two attributes. Now going forward, there is feature selections. Like I mentioned earlier, we found out that the class attributes is as a different has an object value, unlike others that have floats and integers which are numerical in nature. So that clearly tells that the class variable is set for as our targeted variable in this very exercise in this regard. So leaving others with numerical values as our input variables. So with that, we have our target variable set as class and others set as input variables. Now, going further, the inputs are now converted into non-P array. It can be converted into non-P array simply just to make the operation a bit run faster. This is the outcome of what data is generated, as in the function has generated. This is a clear picture of what the class is, with the classes under it. Now, again, in making our model work well and fine, we need to get all the values involved to be numerical in nature. So, having our target variable as an object means so much to this exercise. So, in that regard, we have to, transform the attribute as in the class from object to numerical values. And actually, this is in some cases we could have some of the inputs as well as an input variables having an object. In that regard, you have to transform as well to have a smooth run. But in this very exercise, it is the target that we have as our object, as in categorical in nature. So with that, it shows clearly that it's a classification problem where target variable is a categorical variables. So what we are required to do now is to do a label encoder on the target variable, and that brought us to the use of this function, and goes further to show, this is the print of it, that the classes under the target variable we have has been encoded into between 0 to 6, allocating each values to each class as shown here. So doing a print of that has given us this. You can see here now our target variable now has the values 5, 3, like being displayed there depending on what row is involved. Now going further, trying to perfect our data for machine learning algorithm to work properly. We need to study and understand what we have at hand. And looking at this, we have various ranges of values here, and it's to be better. I mean, very much nice to rescale this value between 0 and 1, in order for this algorithm to work fine. So that is what brought about rescaling, that is regarded as a normalization, and that is what this is trying to do for us here. Try to rescale, and if you do a describe of it, in the end you get this seems similar, but it's in different. I mean, it seems from with the initial describe we did above. But if you look closely at it, you will see that the minimum and maximum is between 0 and 1. And that is what the transformation in normalizing data sets has yielded. So going further, these are actually converted to non-PRA to make the operation work faster, like I said earlier. So at this junction, comes in for us to split our data. What this simply means is that we have to set aside a certain number of data to test our model at the end of the exercise. So with this function, I've set aside a 20. I've set aside a 20. Set aside 20 and 80 for training. So we're actually working on training, which is the 80%. So in the end, the machine we test the machine with the 20%. But now we are training the machine, the model with 80%. So be that as it may, the need for us to train our model starts here. Now that you have our data sets, null application. So I've chosen being a classification exercise. I've chosen to go for random forest classifier, and then under this random forest classifier with this function, there is need to to work on the parameters involved to really get the best of the model we are working on. So these are the features. There is need for us to play around with some of this to set the best feature that will give the model a good performance. So in trying to do this, I did a cross validation. I used a cross validation method to make sure these are randomly picked in order to save time and space, resources. So for some of the required features, the system is choosing among all these values to try and see how it could come up with the best for the model. And in the end, was given this result, the best score with the values or range of values we have we have in that is has given us 0.91 or probably 92 with the best parameters as set at one time an estimator set at 1000, max sample set at 1000. So with that, that's how we could able to get the best score as say 0.92. Going forward, now let's train. We are now trying to, at that point we are still trying to select the best feature for the model. So now that we have been guided enough to get the best parameter to help the model, we now try to train the model. That is what this has done for us with, and the print of it leads us to the predicted value as we have down here. So the model has been able to train. After training the model, we came up with the predictions as shown here. And what this average train error simply means is that the 80% training sets that we use with the parameter given above has really helped the model to be almost error free, and that is what this average training error simply means. So we have 0% error, and then the average test error here is 0.18, and in all the average score here in testing is set as a 9. Well, to some extent this is reasonable. Going further, I did a confusion matrix to tell us to still understand this model properly, and what that shows is that the first one is the training for training, and on the y-axis is the training value, while the x-axis shows the predicted values. This is the second one is for the test set with the tested values on the y-axis and the predicted values on the. So it simply shows that in this case there are errors experienced, as you can see in the purple range. Like let me use this as an example. For the test set, making use of about 225 values to make prediction, detected about 4 errors, and that is exactly what others that are shown here simply means. So, and that is what gives us the average training accuracy of like I was shown here, that there is no error detected to be 1, that is 100%. The training accuracy is 100%, while the testing accuracy is about 92 or 93%. So from here, this is pretty fair, and a dot file was done for this process for what we have been able to achieve here with this function here. Well, and the pickle dump as well was done to save the model in a file for later use. And then, having explored the random forest classifier model, the need for us to try our hand on another model to, at least to compare, to see. Our aim here is to come up with the best for this exercise. So I have chosen to try neural network as a second option to compare which one will be best for this data set. So that is what led us to this function for the second model, that is the neural network. And see, trying to get the model here with this function. The output is set at 1 as indicated up here. Then train the model with this. These are the attributes required: the variables, the epochs that shows the number of cycles it goes in training the model. So this is the outcome of what you get. Doing a printout of it, give the predictions as shown here. That's the prediction. The real value and the predicted value are shown up there. So, and in this what I got the average train error here is nothing to write home about, like 50%. The citation error about 47%, and test error about 50% as well. This is nothing to compare with what we got from random forest classifier. The hyperparameters of neural network could be optimized by search over a grid of trial. So with that means it involves more of a trial and error to really come up with something reasonable and tangible, unlike what we got from a random forest classifier that has a random search as shown. Let's go back to that page. With the random search has really helped in saving time and space in achieving that, with all these values within a few minutes. the system itself is able to get us the best score that could help get the best of our model. So that is that's a review of what I have done on this exercise so far. So thank you very much.